This is a great example of the stateless auto-configuration process that our end stations are going to go through. When the TCP IPv6 stack is enabled on a device, such as a Windows 7 device or Windows 8, the device is going to automatically generate its own link local address. That is the address that is utilized to communicate on the local network. It starts with FE80, and we can examine that on PC1 in our environment by typing in ipconfig. ipconfig. So we can see here that PC1 has generated this particular link local address of FE80:A0027FFFE 5D6D6. So this was generated using the IEEE EUI64 method. It took FE80 and then attached to that an interface ID using the MAC address, putting FFFE into the MAC address in the middle and flipping the 7th bit from the left to create this unique link local IPv6 address. After that, the device also joins the all hosts multicast group. Now, what is the all hosts multicast group? Well, you must always remember that with IPv6, broadcasting doesn't exist. So if you want to communicate to everybody, you need an address to send that message to, that everybody's listening to. Well, this particular multicast address, FF02:1, is utilized by all devices. And if you need to communicate with all hosts in the network, you send the information to FF02:1. So every device has to join this multicast group, or else they will not receive multicast messages that are destined for everybody. After that, they can send out their router solicitation message. The router solicitation message is sent from the link local address, and it is a message that is going to be utilized to find a router in the local network that can provide it with the prefix that is necessary to perform stateless auto-configuration. So the router solicitation message goes out, and the router up here says, oh, look at that. I just received a router solicitation message from this particular device at this link local address. I better respond back with this router advertisement. So the router advertisement has the information that is going to be necessary for the client to go through the stateless auto configuration of its IPv6 address. So it'll identify the prefix that this interface is utilizing, that it's part of, as well as potentially some other configuration flags that might be necessary for the configuration part of it, or even pointing to a DHCP server. A config flag could say, well, if you want to get DNS information, you have to go to a DHCP server. That is possible as well within this router advertisement. Once the client gets the router advertisement back, it's going to generate its own IPv6 address. So it examines that prefix and then appends to that prefix its EUI64 interface ID. And then once it does that, it does what is known as DAD, duplicate address detection. On the link, the device is going to send out a neighbor solicitation message. looking for the MAC address that belongs to the specific IPv6 address. Now, it's its own IPv6 address. However, by doing this, if no device responds with a MAC address based on that neighbor solicitation message, then the PC knows that the address is unique. Nobody has it. Therefore, it can use it. So this DAD process, duplicate address detection, is there to make sure that there are no duplicate IPv6 addresses within this local network. And then lastly, the client still needs a default gateway IP address. And it utilizes the address that was used to send the router advertisement. Now, what address was used to send the router advertisement? It's the link local address of the router's interface. So the default router address, the default gateway for IPv6, is going to be a link local address. And it's going to be that address that was the source of that router advertisement.